Hi, this is Tim. Today we're going to be working with the conveyor trainer from Industrial Concepts again. And in this video, we're going to talk about how to wire it to our PLC. Please take a moment to like this video and subscribe to our channel. We put out at least one automation video a week. And any questions you have, put them down in the comments, especially on this video series. We're going to be looking for your ideas about, what would you like to see? And hopefully we'll be able to get a lot of good, useful content out of it. Now, I'm not going to get specific about here's exactly how to wire it to a Compactlogix or a Micrologix or a Micro 820 or whatever PLC you have, because we have videos about basic input and output wiring. In this video, we're going to mainly talk about how to do the basic wiring of the conveyor, and then yes, this is going to be input 1, this is going to be input 2, and so forth. Now, in our last video where we talked about some hardwired exercises, we used the internal 24 volt of the trainer. In this video, we're going to use the 24 volt on our trainer, so you won't be using this, and in fact, you don't even have to have this plugged in for this set of exercises. Now, we are going to use the relay on this, and we're going to use all of this right through here. So this is where we're going to need to concentrate on our wiring. So first, what we're going to need to do is all of these 0 volts need to be connected together. And this is really easy to do. All we do is we're going to plug it into one, and then we plug it into the next one. And then you can plug this right on top of it, and you'll plug it into the next one. And I'm not going to bore you doing the rest of these. So voila, it's done. Now what we're going to need to do is we're going to need to feed 24 volt to each of our sensors. So that is these 4 and these 3. So we'll plug a wire in there, and we'll jump her to the next one. And then we'll plug into the top of it and go to the next one. And again, I'm not going to bore you by putting all of these on. So voila. So now what I've done is I've actually cut the end off of the connectors, and I put them into a Compactlogix. This is actually the input connector for my Compactlogix. And so input is going to be our first sensor here. Input 1 is going to be our second sensor. Input 2 is going to be our third sensor. Input 3 is going to be that, we'll call it the shiny pusher, or the aluminum pusher is retracted. Input 4 is going to be that the shiny pusher is extended. Input 5 is going to be that the black pusher or the plastic pusher is retracted. And input 6 is going to be that the black pusher is extended. So that's going to take care of all of our input wiring. So again, on the outputs, I've taken and cut the ends off of it, and I put it into the Compactlogix connector. And so output 0 is going to be to our relay, which controls our conveyor. And output number 1 is going to be for valve 1. And output 2 is going to be for valve 2. So at that point, your wiring should look pretty much like this. We do need to do one more thing. We've got to actually power our motor. We have not done that yet. So for that, we're actually going to take and go from the minus of our power to the minus of our motor. Then we're going to take a wire from the plus. This is actually the plus of ours that we've used for our sensors and everything else. That's going the plus of our 24 volt. And we're going to connect it to one side of the left contact on our relay. And then we're going to connect a wire from the other side of it to our motor. Now, a lot of y'all are probably like, man, I didn't follow that. I'm not sure I got it right. Well, there's a reason for it. Because now we're going to talk about how do you test your inputs and your outputs when you're commissioning a system. So I'm actually going to flip this around. One, because I set it up so that the cable, so this will be on the back side where it would reach my trainer, and also to make it where we can actually see the pushers for the rest of the videos. Okay, so I have it flipped around now where we can actually, let's see if we can get that a little further. That looks pretty good. Yeah. So now our input connector And that's going to go into the inputs of our Compactlogix. And then our output connector will go into the first output of our Compactlogix. And then we'll connect our plus and minus 24 volts. Now we're going to add a few more I/O from our trainer just to give us some things to work with. So first, I have wired the green light, the yellow light, the red light, and the blue light to outputs 8, 9, 10, and 11. So we're going to plug that in. And then for inputs, I've wired the green button to input 8, the red button to input 9, the left position of switch 3 to input 10, and the right position of switch 3 to input 11. And so we're going to plug that into our inputs. So now let's talk about how do we test that, because really, okay, we just did a bunch of wiring and we don't know what's right. In fact, I have an extra wire left over there, so I've done something wrong and I could go fix it offline, but I think I'm just going to run through this with you. Okay, so here is the basic wiring diagram that we just went off of. And again, it'll be in the description. And the one thing that is on here that we haven't talked about is I did wire the e-stop into the FP plus terminal. And I recommend you do something like that. Now, I'm not going to call that really a safety circuit. Now, we have some safety videos coming up. We haven't really talked about that, as really we're calling this a kill switch. Because as you're doing this, you may end up chattering this solenoid 100 times a second. In fact, chances are you will if you're trying to work through this and figure it out. So it's good, even if it's just a selector switch, just so you can quickly kill the power to these outputs, it would be a good thing to have. But all right, we did a bunch of wiring here, and yeah, I went through that fairly quickly and fairly vaguely. And part of the reason for that is we haven't really talked about how do you test your I/O when you've wired up your control panel for the first time. Because I see a lot of people go out there and, you know, they spend so much time writing programs programs are important, but they get out there and they just want to get their program working and they never test their I/O. And so they're sitting here making changes in the program and doing all this stuff. And it's like, have you even checked to see if you got the stuff wired right? They're like, well, no, I hadn't even thought about that. So yeah, now that we have it connected, we need to test it. And we're actually going to do this with a blank program. Now, normally you would do this with the program that hopefully you're going to commission the system with, but we don't have one yet. But we can do it with a blank program just as well. So if we open up our controller tags, and we can go to our inputs and the data, and we can see all of our inputs. And we can see already that we have a few inputs on right here, which also we can see right over here. And so that's what we want to do first, is we need to identify these. And we're pretty sure we know where they are, but we still should check them just to make sure. So a couple of things about testing I/O is, one, make sure there's not going to be any damage done when you're doing this. That's the other thing I do see, is sometimes people are a little gung-ho. Don't just go, you know, coming over here, just jabbing the solenoid when you're not really sure. Take a look at what you've got. What we want to do is we're going to go ahead and extend, well, one, we're going to extend what we think is the shiny pusher and see if it extends. Now again, I've checked here, there's no danger. Make sure I keep my fingers out of the way. And so if we go down to our outputs, then our shiny pusher is supposed to be output 1. So if I put a 1 in it, all right, got a problem already. That is actually the black pusher. So I did that one wrong. So let's check output 2. And yes, I've got them backwards. Now, I could simply say, well, okay, I'm going to do it the other way. But okay, I already made that chart for you of what your inputs and outputs are supposed to be using. And if you were starting up a system, then chances are, or please tell me, that you probably have wiring diagrams for it. And so we don't want to just go changing descriptions for what we have. We want to fix our wiring. So in this case, what I need to do is I need to swap valve 1 and valve 2 here. And here's the important step that, again, is often left out, is once you make a change, retest. So we're going to test it again. So output 1 should be our shiny pusher. So if we go up to output 1, we put a 1 in it. Okay, now it is our shiny pusher. And okay, input 4 is now off and input 3 is on. So if we put a 0 back in this, okay, so 3 and 4 definitely are the shiny pusher. But okay, are they right? Because now if we go back to our chart here, no. Input 3 is supposed to be retracted. Input 4 is supposed to be extended. So again, I have them backwards. Now, well, we haven't written a program yet, so I could just change the descriptions. But I made you this chart, and hopefully you've been going by it too. So I need to fix this. So this is going to be switch 3 and switch 4 right here. We're going to swap those two. And again, the important part is now we need to retest. So we are retracted, and we see switch 3 is on. So I put a 1 in, and yes, switch 3 went out, switch 4 went on, so we're good there. So now, let's go ahead and test output 2. And you know, I've been typing 1s and 0s in here. Another way you can do this is you can actually, well, there's two ways. You could just right-click this, and you're going to have to toggle a bit here. But also, one thing I love about Studio 5000 is it tells you the shortcuts right beside of it. So I can simply highlight this data tag here and press Control-T. And there you go. That one's going to extend. Okay, looks like I have the same problem again as I did last time. Is 5 is supposed to be retracted, and 6 is supposed to be extended. But you can see right now we're retracted, and we're showing input 6. And if I extend it, we show input 5, and 6 goes off. So I have these backwards again. I'm not doing really good at my commissioning here, but that's all right. That's why we test. So we're going to swap that wire with this wire. And again, we retest. So now I'm extended and I'm showing 6. I retract it, and now 5 is on. Okay, so now we have our 3 sensors. And this one over here is supposed to be input 0. So when I stick my hand across it, we should see input 0 come on. And we don't. We see input 2 come on. See, guys, I'm not doing really good with my commissioning. But okay, let's go ahead while we're here and let's stick an aluminum piece under our shiny sensor. Gotta wait on the air compressor. By the way, if you don't have an air compressor or it's like an office situation, listen to this thing. I don't even know if you can pick it up on the mic, but this is the world's quietest compressor. It's actually sitting right underneath me. I'll put a link to it in the description also. At first, you're going to look at this and say, okay, well, why am I getting 2 inputs when I put this in here? And move that over. We're getting that input 2 off of this sensor here because it can sense a good distance. Which one comes on when it's right over top of it? And that's going to be input 1. So I did get that one right, which means, yeah, this one's wrong too. So this one's saying input 0. It's supposed to be input 2. So I have these 2 sensors swapped. So over here, I need to swap my photoelectric sensor and my capacitive sensor. And again, we're going to retest now. So first, we put one here, and now we have input 0, which that's what that's supposed to be. We bring this down to here, and yeah, input 1 is switching, and then this last one, input 2 is switching. Okay, now while they're fresh on our mind, we should go ahead and label these. That's, I mean, a very important part of it. So input 0, I'm going to call conveyor part present. Ooh, okay, well, let's wait a second. Yeah, I don't know if y'all caught my mistake here. I'm sitting here labeling this. This is output 0, not input 0. So I was getting ready to make a big boo-boo. Okay, well, while we're on our outputs, we do know output 1 was our shiny pusher. So we can go ahead and label that. So let's put shiny pusher solenoid. And I like labeling kind of what they are, whether a motor or a solenoid there. That way, later on when I'm like, the pusher's not working. I know what am I looking for exactly? How's this thing move? So then number 2 is our black pusher solenoid. And then we actually haven't tested our conveyor yet. So let's go ahead and toggle that. Okay, and our conveyor runs. So let's put that as our conveyor motor. And now let's go up and label our inputs. So input 0 is our conveyor part presence. So we're going to put conveyor part present. All right, and then 1 was shiny part present. And 2 was black part present. Okay, then let's make sure we get this right. So let's look at it again here. So input 3 is our pusher, our shiny pusher retracted. So shiny pusher retracted. Then 4 is shiny pusher extended. 5 is black pusher retracted. 6 is black pusher extended. Okay, so that takes care of all what I'll call our field I/O. Now, one thing we haven't tested is we actually have some buttons that we added also, and we had some lights. Yeah, we need to check those too. As I said, it's important to check everything before you really try to debug your machine. So we're going to press our green button. Okay, and I'm seeing input 8 on the PLC. And yeah, okay, actually I have input 8 and input 9 have 1s in them right now, but I let off of it. That's definitely input 8. So that's going to be our green button. Okay, and then this one already has a 1 in it. And when I press it, it goes to a 0. And that's because I used it normally closed on our red button. So we're going to label that as our red button. And then we use switch 3 down here. Okay, and we do have an input on, so I'm going to switch that off. Okay, so that is definitely switch 3 to the right. And that's all we're going to label it as for now. So switch 3 to the right. And if we've done everything right, then yes, we got a 1 there. So this is going to be switch 3 to the left. And that's going to give us a good amount of wiring that we can use to do a lot of neat exercises with this. So in future videos, well, we're going to do some basic start stops of the conveyor in the PLC. We're going to make switch 3 into a handoff auto to give us some options on controlling it. We're going to talk about that we could simply see, when we see the sensor, we could time this and not even have these sensors. And why that works sometimes, but most of the time you're better off having a sensor instead of relying on time. Obviously, we're going to do some sorting because we have shiny and black pieces. I'd like to come up with something of why we would reverse this. I guess one thing, I could just run it back and forth between the switches, but I like to usually have some real world example. And I'm really struggling because usually I'm always told don't reverse the conveyor unless it's jammed up. So any ideas on why we would ever reverse the conveyor? I'd love to hear that. And then we're also going to talk about, obviously probably the most important thing you need to know is when we have this working perfectly and it quits working perfectly, how do we adjust the sensors to get it back going? So a lot of good content coming up on this. Put any suggestions you have down in the comments. Till next time. Hi, this is Tim.
And this is Amber of TW Controls. We run the automation store. Hey, thanks for finding our channel.
Here's a playlist with some similar videos.
And YouTube thinks you'll like this video.
Please like our video and subscribe to our channel.
And if our videos have helped you make some money and you're not using our products, please consider supporting us on Patreon.
Till next time.
See ya!